Welcome to my first basic coding tutorial about making a prefab level generator. I'm Atlas the Titan, and in this tutorial I'll explain how I made my sweet but simple random level generator that uses prefab rooms and connects them together. But before I do that, I'd like to tell you why. At this moment, I'm working on a VR co-op game where the player will be a thief who'll steal art from a museum. The game is going to be kind of an arcade, which means that people will have to be able to play it over and over again. Now, we all know that playing the same levels over and over again is kind of boring. Of course, you could just make a lot of different levels and maybe even keep adding some in updates. Maybe even a real level editor so that players can make their own. Wait a minute. That's not actually a bad idea. But anyway, as we know, making levels or even a level editor takes time, effort, and a designer's brain. Now, I am really bad at level design, and as a student I have absolutely no time. But I figured that the best way to fix constants is to throw in some randoms. That's when I got the idea to make a level generator. I've seen some tutorials online, but they all included either complex ideas like the wave function collapse system that Oscar Stolberg used in his Bad North game, or even simple ideas like the 2D room generator tutorials by Black Thornprod. All of them explain very interesting ideas, but they wouldn't fit my museum level generator. I needed a generator that could use prefab rooms and connect them together, simple but sweet. I found some tutorials online, including the series by Project Shasta, and I figured I started to make one and explain how I made it as easy as possible, so that maybe some designers and starting developers could maybe copy and paste my code and hopefully play around with it and understand how it works. But enough of my whole backstory, let's begin with the tutorial. Alright, to start off we'll make two scripts, one called the maze generator and the other called the room behavior. We'll start with the room behavior script. This script will hold two variable lists of the doors and colliders of your prefab. The doors will eventually be used by the maze generator script, but the colliders will be used by the check room function. The maze generator script will use this function to check if the rooms will overlap with any other rooms. Once it's placed, the function uses the new position the maze generator calculated for it, and it will also use the given layer mask to only check for other rooms. Next up, we'll make a simple test room. For now, I've made a simple square room with 4 doors on each side. Make sure that you place the doors exactly on the edge of the ground and place the walls a little bit inwards. This will prevent the walls from intersecting later. You should also add 1 or more box colliders to your room and align them so that they are merely millimeters inwards from the door position. Otherwise, the rooms will constantly intersect and the maze generator won't be able to place any rooms. Last but not least, slap that script on the base of your room, add all the doors and colliders you use. And before I forget, you should make a new layer mask called room and change the game object that has the box collider you just made to that room layer. And make absolutely sure that you only change that object, because if you also change the walls and doors to that room layer, then the maze generator will also have troubles placing your rooms. Next, we're going to focus on the maze generator. This bad boy will do all of our work, hopefully as fast as possible. But first, let's start on making a room appear. We'll start by writing down a few variables that will hold the room prefab, the room layer mask, and the amount of rooms we want to make. We've also made a list of our built rooms so we can recall them later. Next, we'll write a little instantiation of the start function, and I'd like to also make a parent object that will hold our maze. And finally, we'll add our room to the built rooms list. Go to the inspector and insert all of your variables, and let's see if it worked. Alright, great! That's our first step. Next, we'll do the hard part, and that's connecting rooms together. To connect our rooms, we'll first have to add a little more variables to our script, mainly a private holder of the current and joined rooms, and holders for our current and joined doors. We'll create a little if statement in our update function, which will check if the amount of rooms has decreased to 0. If they haven't, we can make another room. I made a function called placeRoom that uses one of the build rooms as a start. The function also checks if the build room already has used up all its doors, and if it did, it'll remove that room from the list. Next up, we'll instantiate our room, but if you use multiple rooms, you could also make a random function here. But, for the sake of our demonstration, let's just make one single room. We'll instantiate it, and we'll get a random door for the next function. The random door is a quick function that takes a random door from the current and joined rooms. These doors will have to connect, and for that we're going to change their rotation and position with some quick maths. First, we'll change the room's rotation. For this, we're going to use the delta angle between the given doors and their Y rotation. The delta angle is basically the difference in rotation between the current float and the joint float. For example, we have two rooms, with each different doors. The current room in this case is our joint, and its door has an angle of -90 degrees. The joint room will have our current door, which has an angle of 0 degrees. So, if we get the difference from 0 to -90 degrees, we'll have -90 degrees. Now, if we set the room's rotation to -90, then both rooms have the same angle, but we want them to connect. So we'll multiply the rotation with 180 to turn it around, and voila! The doors can connect. Last but not least, we'll calculate the position by doing some simple subtractions of the door and room positions, and the room is correctly placed. But, before we place the room, we have to do one last check, and that is for the room behavior script to check if it intersects with any already built rooms. If it does intersect, then the joined room is destroyed and the update function starts again. But, if there are no other rooms around, then the joined room is placed, the doors of the joint and the current room are destroyed, and the amount of rooms can subtract. Now, to see the full system in the works. And tada! The script works, but it's kind of sad seeing only a 3-room maze, so let's increase the amount of rooms and hit it again. Nice! Well, that's my tutorial on making a simple but sweet prefab level generator. I've put a link to my project in the description. If you open mine, you can also see that I made a list of multiple prefab rooms and connected them together with the same script we just made. And I've also made a little demo of my museum heist game and put it on my itch.io, and I would really appreciate it if you could maybe check it out and give me some feedback. But for now, I'd like to thank you all so much for watching my first tutorial. I'd love to hear what you guys thought about it in the comments, and as always, I'd like to say, see you later, alligator. In a while, crocodile!